All right, so example 5. So the table below shows the average temperature per month in Atlanta, Georgia. Information was found at the World Climate website at www. You can read that.
I can't.
Well, you're not going to look it up anyway, so. All right, so we've got these numbers here, and now we're going to go graph them.
We are?
Yes, we are. 5A says we're going to plot the data below, and notice that they approximate sinusoidal behavior. All right, so let's do that. All right, so you're going to plot your points. So we know our X's represent what variable?
Months.
The months. And our Y's represent the temperature.
I don't know how that sounds. Oh, I guess from year to year.
All right, and after you get your plots pointed, go ahead and draw your line. Yeah, because we're going to connect them because in between those months, it's not just on January 1st that it's got the temperature, right? The temperature, something's going on during the whole month of January. So you need to connect those. Connect those points there. And so does it appear to be sinusoidal?
It's only half, though.
Okay.
It's not a full.
What does sinusoidal mean? It's going to have that wave. It is following some type of a pattern. It's periodic, right? It's going to keep doing the same thing over and over. Why? Why would the temperature do the same thing over and over?
Because it depends on seasons.
Yeah, it depends on the season. We know that January and December are going to be really cold, right? Or colder than the other months. We also know that July and August are going to be hot. So, therefore, it is periodic because the average monthly temperatures don't really vary, and they repeat the same year to year. All right, so let's move on to the next question then. So we did our graph. Why does it make sense that the average monthly temperatures can be modeled by a periodic function? You just told me that. What did you say?
Follows the seasons.
They model.
Yeah, the temperatures are cyclic. Means they follow a cycle. So they're periodic with the seasons. And repeat year to year. All right, so 5b here says let's model this graph with the sine function in the form of y equals a sine of bx minus c plus d. Use your data plot to estimate the amplitude, the period, the vertical and horizontal translations. Use these values in the sinusoidal equation and test your model by using your calculator to graph it on top of the data. All right, so we want the equation and we want it in sine form. So we need to find A, B, C, and D. Let's start with A. What does A stand for? What's going to help me find it? A is my amplitude. Do you remember how to find the amplitude? We talked about this before.
Isn't it the
No?
Absolute value of A.
It is the absolute value of A, but I don't know what A is. That's what I'm after.
The maximize minimum divided by 2.
There you go. It's the maximum minus the minimum
Man, you're a genius.
divided by 2. Remember, it's from the midline to the top or the midline to the bottom of the graph. So it's half of the entire graph. All right, so on this one, look at your table. What was your maximum value?
88.3.
Good. Minus, what's the minimum value?
51.6.
Okay. Now, if you're going to put that all in your calculator at one time, make sure you use parentheses. Otherwise, do the top and then hit enter and then do divided by 2. Either way, what do we get?
18.35. Yeah, 18.35.
Good.
I like the 26.
So that's A. All right. B. What do we use to help us find B? No? Yeah, what's 2 pi over B? What is that? That's the period. So remember, the period is 2 pi over B. So what is the period of this one?
I don't know. We don't know.
1 year.
1 year. So everything was in months, right?
Yeah.
So 12 months. So 12 is equal to 2 pi over B. So make that into a fraction. I'm going to cross multiply. So 12b equals 2 pi. And what is B?
1 over 6.
Good. We're going to come back on C, okay? We'll come back to C. You want to leave it to the end. So let's find D. What is D?
The vertical.
It's the vertical shift. What else is it? What else is located at that point?
The midline. Oh.
That's also the midline.
That's
All right, so how are we going to find that?
Isn't that maximum minus minimum?
No.
No. Wow.
Would it be the minimum?
No, it'd be the average.
Average, yeah. 88.3. Right.
Okay, so you could do the maximum plus the minimum and divide it by 2. Or you could take your maximum and subtract out your amplitude. Either one of those will work. Or you can take the minimum and add the amplitude, okay?
88.3 minus 18.3.
All right, so if you're using the maximum minus the amplitude, you would say, what, 88.3 minus 18.35? Either way you do this,
Nice.
you get 69.95. All right, so we've got everything but C. So let's fill out what we've got so far. So for my equation,
0.01 more.
we know A, right? What is A?
18.3 plus 8.
You know what? I'm going to write it like this. I'm going to do Y equals.
No, don't do it.
Sine, parenthesis. They said they wanted B inside the parentheses. So what is B?
B is the pi over 6.
X minus, we don't know C, do we? So just put minus C. And then what is D?
69.
Plus 69.9.
All right.
I think I left my phone. Someone flushed it on the toilet.
All right, so here's what we've got so far. We just got to find C. Now, if they had given us a nice graph, it wasn't based on real-world data, so it'd be more like what we'd consider perfect, okay? Then we could use the graph to help us here. But since, one, we graphed the graph by hand, so we could have made, we don't know exactly where 88.3 is, right? Because it jumped from 85 to 90, so we had to guesstimate that one. And it's based on real-world data, which is not perfect. Let's work this out algebraically. So look at what we don't know. We don't know Y, we don't know X, and we don't know C. Well, in order to solve for a variable, remember, it has to be the only variable. So if I need to solve for C, I need to know a y and an x value. Do I know any y and x values?
Yeah.
I got all those ordered pairs that we graphed, don't we?
Yeah.
So let's just use the first one. So it was 1 and 51.6. So that's going to be our x and our y. So let's plug that in. So 51.6 equals 18.35 sine pi over 6 times 1 minus c, and then plus 69.95. And let's just slowly go through this one piece at a time and solve for c.
Wow.
So first thing I'm going to do is, you see inside that parentheses, those are being multiplied. So 51.6 equals 18.35 sine of, what's pi over 6 times 1? Good. Minus c plus 69.95. Now notice that c is inside that sine function, okay? So we cannot separate those until the very, very end. And then we'll talk about that then. So how can I get that sine of the pi over 6 minus c by itself?
Subtract the 69.95.
Okay, subtract the 69.95. And so what does that give us?
Negative 18.25.
R amplitude.
Now it's negative 18.35
Negative.
equals 18.35 sine pi over 6 minus c.
Oh, that's a rip.
Now what do we do?
Divide over the 8.
Divide over the 18.35.
So it'll just give you negative 1.
So negative 1 equals sine of pi over 6 minus c.
You should have went into the front office. That's where she was.
All right. So let's think about this. What if I told you that negative 1 was equal to sine of theta?
I think you're crazy.
Well, then you're a math teacher that has forbidden knowledge.
Okay, well, no, I just remember what we studied in 4.8, and so I need to know what that angle's equal to, don't I?
Yeah.
So if I want to switch these two where it's equal to theta, what's that called when you switch the input and the output?
Inverse.
The inverse. So we're going to do the inverse sine of negative 1, and that's going to equal theta. Well, the only reason I wanted you to write it as the inverse is so you'll remember that we're dealing with an inverse. And what quadrants do we look at for the inverse?
1.
1 and 4. All right? Is sine x or y on my unit circle? Remember, r is 1, so it's either x or it's y. Which one is sine?
No, it's Y.
Sine is y because it's y over r. All right, so where is y equal to negative 1 on my unit circle that's in quadrants 1 and 4?
3 pi over 2.
3 pi over 2. Now, right location, wrong angle. Because remember, if it's in quadrant 4,
So it'd be negative pi over 2.
we have to subtract 2 pi from it. So we're going to use the negative pi over 2.
So you want us to write down the blue right there?
I would.
Oh.
All right, so what that tells me then, I'm going to write what we kind of wrote over here. So we said negative 1 was equal to sine of theta, correct? And we said our theta, once we solved it, was equal to negative pi over 2. But look, what is theta? What is theta in the place of?
Pi over 6.
Pi over 6 minus c. So we know that pi over 6 minus c is our theta, and that's equal to
Pi over 2.
negative pi over 2. So now we just have to solve for c. How?
Subtract over pi over 4.
Subtract the pi over 6.
Common denominator.
And so we got negative c equals. Now guys, do I really want you to be able to subtract by finding your common denominator and stuff? Yes, but is that the goal of this lesson? No. So if you have to, what would you use in your calculator to help you figure this out?
1/2.
Negative 1/2 minus 1/6. And what does that give me?
12.
How about we use our calculator and try it?
0.66666.
Math enter.
Negative 2 or 3.
Oh, so shucks.
How did that give me? Oh,
And we can just divide by negative.
So this is negative 2 pi over 3 then, right?
Yeah.
And then divide by negative 1. And so c is 2 pi over 3. Now can we write our equation?
Yes.
All right, so I'm going to do that here at the bottom. So f of x equals your a sine pi over 6x minus your c plus d. Now how can I check and make sure that this is correct? We're going to put it in our calculator. Do you want to be in degree or radian mode? Radians, why? Because I have a pi over 6 and a 2 pi over 3. Those are radian angles, radian measures, aren't they?
Also,
So you need to be in radians. So put that in your y equals and look at your table. Do I expect my points to be perfect and exact? No, the equation will give me perfect exact things in a perfect world. Ours wasn't perfect and exact. It was real world data. But should they be close? Yes, they will be. So try that.